Uh-oh. Someone just said they got your IP address. You're scrambling, you're confused. What does that mean? What even is an IP address? Today, we're gonna be talking about IP addresses, what they actually mean and do for your devices, and how you can protect yourself from people grabbing your IP address. So let's get right into the video. Drop the intro. Pretty much everything in your house that's connected to the internet, i.e. Wi-Fi or through an Ethernet cable, has an IP address. IP addresses are dynamically assigned to your device through a protocol called DHCP. In networking, we call these devices that are in a network nodes. So when you hear me say node, that's what I'm referring to. DHCP allows your router to dynamically assign your IP address. What does that mean? This means that IP addresses in your network are from a pool. And when your device is done using that IP address, that address is then returned to that pool and it can be assigned again by your router. In your network, and when I say your network, I'm talking about your private network, like your casa. And also some of you might be familiar with the term LAN, which means local area network. You have your nodes, which are connected to a default gateway. A default gateway for most of you is just your router, the black box with the Wi-Fi password on the back. Once your computer obtains an IP address from your router, other devices don't see this private dynamically assigned IP address. Your device communicates through your default gateway. If your device wants to send some data, let's say to Google, it'll send the data to your default gateway, and then your default gateway will send the data using its own public IP address. Your router has a public IP address and a private IP address. So the node in your LAN, or your computer for example, sends data to your default gateway's private IP address. The default gateway handles this data and then through its public interface sends it over to Google. When Google wants to send back data to your computer, it sends the data to your IP address, but only your gateway actually knows how to access your node through the IP address, which is why it's called a router. Makes sense, right? There is another piece of information that identifies your devices, and this is called a MAC address. Unlike your IP address, which is dynamically assigned, MAC addresses are static, meaning that they're assigned once a device is created, and they never change. I like the analogy that my networking teacher used, which is that MAC addresses are more like social security numbers, whereas IP addresses are like phone numbers. Like, hey buddy, you can reach me through this phone number. It might change in the future, depending on if I get a new phone or whatever, but my social security number will never change. MAC addresses come into play because routers will use these MAC addresses to route your IP addresses. They basically link them together to know, okay, this device has this IP address. I'm trying to send it to this IP address. Which MAC address has that IP address? Sorry if it's getting a little confusing, but I'm hoping that the graphics that I'm showing are helping you understand. The way that routers match these MAC addresses to IP addresses is through something called ARP. And ARP stands for Address Resolution Protocol, which is perfect for what we're doing. We're trying to resolve where these IP addresses actually go. So when devices don't know each other's IP addresses, they use ARP protocol to discover and figure out which path to take to get to a device's MAC address. There are two different types of network communication, TCP and UDP. And when a router doesn't know where to send data, they'll use UDP to broadcast the data and say, hey, who has this IP address? When the destination node responds saying, hey, I have the IP address, send me that data, the router then logs that data in its ARP table and for future reference can be like, okay, you're accessible through this port. This is kind of similar to like your browser cache, for example. If you look up YouTube after clearing your browser cache, you're going to be asked to log in. But the more you use YouTube without clearing your browser history or your cache, it'll save your login information. It'll be easier to access through the network because your browser doesn't have to go find where YouTube's IP address is. It's already stored it in its cache. A simple tool to find out what addresses your devices are communicating with is Wireshark. Wireshark is an application that displays all the network connections that your device is interacting with. If you want to isolate the IP addresses that you're communicating with, you can write TCP in the filter, and this will display all of the devices that you are communicating with. We're going to be talking about TCP and UDP in a future video, so I'm not going to go too in depth on those. Although your IP address is dynamically assigned, it's still vulnerable to attackers. Cyber attackers looking to pull IP addresses can still find your IP address through various malicious ways, such as phony links and sketchy sites. These methods isolate your IP address. Even with Wireshark, they can find your IP address, especially if you're not using ding 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 a VPN. VPNs allow your network to go through one more layer of security before reaching the outside world of the internet. Even though, at most, what cyber attackers are going to be able to get is your public interface, i.e. your router, this can still allow them to do things such as DDoS attacks, where they send excessive amounts of data to your LAN, slowing down your entire network. Trust me, if you're a gamer, you probably experienced a DDoS attack. Maybe you piss someone off in a game, and they say, oh, you're getting DDoS. Your game starts lagging, and then you crash. This is because your network is trying to handle all of this data, and it doesn't have enough bandwidth to support all of this data that they're trying to send to your router. So finally, I just want to talk about IP addresses and their structure, so that you can read an IP address. One thing that you guys can do to see your own IP address is go into command prompt on Windows. There is probably a Mac way to do this, but I don't have a Mac, so I'm not really sure. But in command prompt on Windows, you can type in ipconfig, and you will see your IP address along with your gateway's address and something called a subnet mask. I'm sure recent editing is going to put how to do it on Mac for you Mac users. So what do all these numbers mean? IP addresses are comprised of 32-bit numbers. If you break it up, you got 4 8-bit numbers, which means that these numbers can have a range from 0 to 255. A subnet mask is something very useful to determine things about your network, such as the size of the network and the network ID. These components can easily identify if the network is a small LAN, such as a home, or a big business. It can determine how many people are allowed to use the network, and it can determine the default gateway of your router. Even if someone doesn't have your IP config sheet, they can still find all this information out if they have the subnet mask and an IP address. Let's take this IP address for example, and we have this subnet mask. So basically how this works is the subnet mask is made up of ones and zeros when converted to binary. Wherever there's a 1 in the subnet mask, you will leave that on in your IP address. So then you get something like this. And this right here is your network ID, essentially the base ID of the network. So from here, we can see that the range of IP addresses is from here to here, giving it a size of this. This is how many different IP addresses you can have, maintaining the network part of the IP. The network part of the IP can't be changed. And this is what the subnet mask tells us. It tells us the part of the IP address that cannot be changed. So I know that IP addresses can look a little daunting, but I hope that this video gave you some insight on how to read IP addresses, what they're used for, what they even are, and I hope you guys take care of your IP addresses so that people cannot pull them. While they are dynamically assigned and you can get a new IP address basically every time that you power on your device, it's very important to safeguard these so that people cannot force communication with your device without you knowing. I hope you guys learned something in this video today, and I hope you guys have a great day. Download Wireshark and join a couple video games. See how many IP addresses you can find, but don't do anything malicious with them. That's not what it's about. Educational purposes only. I'll see you guys in the next video. Peace out.